Hello, this video is going to introduce the Meta HTML library and talk about how you can contribute to it. So I'll share my screen, and I have my Firefox window right now pulled up to the GitHub page for this Meta HTML library. And what the purpose of this library is for extracting metadata from a web page. So let's take a look at an example. Here we have an article from the New York Times, and there's lots of interesting metadata about this article. For example, we have the authors listed right here, and we have the publication date, February 19th, today, but it was also updated at 6:56 p.m. Eastern Time. And yeah, there's lots of other information here buried inside of the HTML as well that we won't look at. And our goal of this library is to extract all that information, process the HTML, and return this information in a way that's easy to process. So here's a big list of some of the things that this library can extract from the HTML. So the first one is it can decide whether the web page was an article or not an article. So this New York Times article is an article. It's published on a specific date and has this big body of text about what it's about, has a title at the top. But let's take a look at an example of a web page that's not an article. Here is a web forum. There's no like one particular date that this was published because it's constantly changing as people post new topics down here. And there's really no like one particular or set of paragraphs that I can point to and say that's the content of this page. And so because of that, it's not an article. So it can determine that for us. It can determine what language the web page was written in, whether it's English or Spanish or Chinese. Currently supports about 100 different languages that it can identify. And it can do the publication time. So I mentioned that already of the New York Times article. Come back over here, just February 19th, 2021. Can look through the HTML, find exactly where that is and pull it out. And it does a number of other things as well. But in this video, I'm going to focus on just these first three right here. Let's see, so the rest of this video, what we're going to do is I'll first show you how to use this library to extract this information yourself. And then I'll show you how to generate test cases for this library. So test cases are very important for this library because it's kind of described right here, that all this information is encoded in the HTML at various locations. But one problem is that there are so many standards for encoding this information that every web page just does it differently. And even if they're following a standard, sometimes they just don't follow it correctly. Or some pages like the BBC, they said, hey, I don't like any of those standards, I'm going to create my own standard. And so the existing tools to extract this information, they tend to not really work. And actually, it's even worse than that. They not only don't work, but they will return totally incorrect values. So if we were to use one of those tools on this web page, rather than getting this right here, I've gotten values that would be, say, in the future from like the year 2055, or way, way in the past, like 5000 BC, things that are just obviously no web page was created in those timeframes. So this library, the key sort of thing, the key addition of this library that other libraries don't do is it has all these test cases that make sure that the program works on a very wide assortment of web pages. Currently, there's about 10,000 web pages that have test cases supported. And my goal is to eventually have hundreds of thousands or even millions of test cases so that it's really like a very, very large fraction of the web that is known to work with this library. Generating these test cases, though, requires a fair amount of manual work. Not a lot, but it does require human intervention. And so that's one way that you can contribute to this project is by helping me with those test cases. Okay, so now let's talk about how do you actually use this library. And the first thing is you have to download it. And downloading this library is a little bit different than other GitHub repositories because of all of these test cases. Each one of these test cases takes up a couple of megabytes just by itself. And I mentioned there's almost 10,000 test cases, so that's many gigabytes of data just in the test cases. And not only do you not need that to use the library, you don't need the test cases just to use the library. But if you were to download all of that, it'd take a long time, hog up your internet connection, eat up your hard drive space, things like that. And it would actually make the test cases that the program runs locally on your own computer significantly slower. So what these instructions right here explain how to do is to do what's called a sparse checkout in Git terminology. And this downloads everything about the repository except for the test cases. So that means that the download will happen really fast, and you can use the library just like normal. You'll even be able to add your own test cases following these instructions. But then when on your own computer, you can only run the test cases that you've just created. But when you upload it to GitHub, committing it and pushing it, then GitHub will, in the cloud, run the full test suite for us using their computing resources instead of yours. So that's the purpose of this relatively complicated cloning instructions. If you are interested in the details of this sparse checkout, this blog post right here from GitHub has a pretty good explanation of how it works under the hood. Okay, so now I'm gonna switch over to a terminal and just do a quick example of how to use this library. And I'll use it on this New York Times webpage that we were working with before. So I just copied and pasted that URL right there. And let's switch over to a terminal. And you can see that I'm in my in a meta HTML folder right now. I already cloned the repository with that sequence of steps right there. And so we have access to all the files that we need. And what I can do is there's a program called test_golden.py in this repository. And this is the program that provides sort of a simple interface, simple command line interface to the library. And it's also the program that's used to generate test cases. In order to use this program, you just do Python 3, then tests/test_golden.py, and then you put the URL that you want to extract information from. In this case, actually in every case, you put the URL inside of single quotation marks. And this ensures that the URL will get properly passed into the program. It takes a few seconds for the web page to download and the program to run. And you can see at the top, it's giving us some messages about downloading the web page. You can ignore those messages. And the important thing is this right here inside of the curly braces. This is the sort of simplified output of the meta HTML program. And so you can see, like we mentioned before, the type, in this case, it's saying it's an article, which is great. And then there's the timestamp published. In this case, it also includes a timestamp that the web page was modified on. We saw on the in the HTML, it had a little field saying that it had been updated. So that's why there's both a published time and a modified time. And this language is in English. Let's take a look at these timestamp fields. They're a little bit confusing. Timestamps in general can be very confusing to work with. But the format of this is that there's a high and a low, and this provides an upper and a lower bound on the time that the information was actually published on. So here you can see that both of the high and low match each other up to the seconds field of the timestamp like this, and they're different after that. In the high field, it's pegged to the maximum possible value, and in the low field, it's pegged to the smallest possible value. And what this means is that the New York Times webpage for the published timestamp gave us accuracy up to the seconds field. And again, I know it's up to the seconds field because that's when the high and the low match. For the modified field, actually, they give an even more precise timestamp down to the microseconds. These are microseconds over here. And I know that it's a more precise timestamp because the timestamp matches up to the microseconds field. New York Times is they've been sort of leading a lot of the digital revolution in print, and so they do a great job with their timestamps here of making them very, very precise. A lot of other newspapers, though, and just websites in general, provide much less precise timestamps. And I'm going to real quick switch over to the GitHub page again, just to show you an example of what that looks like. So down here under this testing overview, there's a couple of example outputs of this test_golden program on a few different web pages. CNN here is another great example of a website that gives sort of very detailed timestamps for the web pages. In this case, they're down to second level accuracy in both the timestamp modified and timestamp published. But if we scroll down one more, here's a sort of a more local newspaper, the Windermere Sun. And if you look at the output here, you can see that they, first of all, they only provide a timestamp published, but their accuracy is only up to the day field. They say it's published on January 10th, and they don't provide any information about the specific time, the hour, the minute, or the second. So this is, yeah, exactly how much detail is included in each of these fields, and even whether the timestamp modified field is present or not will depend on exactly which web pages you're looking at. So that's actually, and as far as like extracting information from a web page, that's pretty much all there is to it. You just do that and you get this JSON object out, and it's then you can process the JSON object just like you'd process any other JSON object. If you wanted to get more detailed meta information, this command has a parameter that you can pass --full. You can put it anywhere, but I'll put it right here, --full. And I'll hit enter. It'll take a second to run here. But we'll get a huge, big chunk of output, a giant JSON object with all the different metadata that's extracted from this web page. And let's see, when you run this full command, it does has to load up a couple of extra additional libraries inside of it. So it takes a little bit longer to run, but there we go, there's the output. And you can see that it's just a lot of output here. I'll scroll up a little bit and it just keeps going and going and going. Yeah, so a lot of information contained in these web pages can be extracted with this program. Okay, so that's, yeah, again, that's the details on how you use this library from the command line. And the last thing I want to talk about is how you actually add new test cases to this library. So like I mentioned before, this library, my goal is to have it work on lots of different web pages. And currently, there's about 10,000 test cases, different web pages that it works for. And but I would like to have more than that. So right now, the majority of those web pages are English-speaking newspapers or English-speaking blogs, but I'd really like to have other languages supported as well. I only have about, say, maybe 20% of the test cases right now are from non-English languages. And even in terms of English, right now I'm really focusing just on, or the test cases that I currently have are sort of mostly just major websites like CNN, and a lot of, say, more local newspapers haven't been added, or like personal blogs, things like that. I'd like to have test cases for lots of different types of things. So there's still a lot of work to do to add test cases is the basic summary of that. In order to add a new test case, there's just two fairly simple steps if everything goes well. And I'll talk about how to identify if things go well versus not go well, and what to do if things don't go well. So the first step is just what we've already done before. You just do the golden test to extract the information from the web page without the full command. So like this, no parameters, and you get this information right here. And then you just have to check to make sure that the timestamp published is the same as what's written on the web page. So here the timestamp published is February 19th, 2021. And if I were to go back over to the web page over here, look for the timestamp, and we see that also February 19th, 2021. And that's great. So it means that it's extracting the correct date out of this web page and did not get confused about any of the other dates that are present on this web page. There are Yeah, I mentioned before, this timestamp's a little bit more accurate than that. So inside of the HTML, it's not displaying it to the user, but there is this uh, more detailed timestamp, and that's what it's actually looking at. You don't have to check the detailed timestamp. You just make sure that the timestamp here matches whatever you're visually able to see on the web page. Every web page is going to have a different location for this, so that's why it really does require a human annotator to look at this and manually make sure that those dates match, because yeah, the computer can't fully automatically figure out where the date is on the web page yet. So that's the main thing to do. You should also just check that the language is correctly identified as whatever the language is. And if we are in an article type, which we were, that the type here says article. And then there's also this URL field that just is whatever URL we downloaded, and that'll always be correct. Yeah, if the timestamp modified is present or not present, that's okay. You feel free to ignore that and just focus on the timestamp published aspect. So now that we have manually verified that this timestamp is correct, or sorry, yeah, not just the timestamp is correct, but the entire output here is correct, we want to save this test case. And in order to save it, register it for future work that this test case passes, that this New York Times article is correct, we just rerun the command that we ran before, but we're going to add a -- save parameter to it so that it saves it. And so that you can see it and it doesn't go off the screen, I'm just going to move my cursor over here to do -- save like this. I could have put it at the end, but then it would have gone split in half. So that's why I'm putting it here. -- save. And it's going to rerun the test like this. It takes a little bit longer because it's doing a slightly more thorough thing in the background. It takes about like 10 to 15 seconds or so. And what this is going to do is it's going to create a new test case file that every time PyTest gets run, will now verify that the code continues to work on this New York Times webpage. So that's great. And that's essentially all there is to doing to creating a test case. The next thing that we have to do, though, is we have to add this test case to the GitHub repository. And so let's talk a little bit about which files are created when we run this test case. If I run the git status command, git status like this, we'll be able to see that 2 files have been created. And you can tell from the names that they're both related to this web page. Inside of this .cache folder, .cache right here, this is a copy of the actual HTML that was processed to generate the test case. And we have to save this HTML in sort of its raw form so that maybe sometime in the future, New York Times will modify their web page so that things are formatted differently. And we want our test case to still work or to still pass for things that were downloaded at exactly this time. So it's important that we retain exactly what this web page used to be. It's also the case that, so it takes a little while to download a web page, not too long, but a couple of milliseconds, half a second or so. And yeah, for just one web page, that's not a whole lot of time, but when you have 10,000 web pages that you're working with, that really adds up. And by caching all of this, we save ourselves a lot of time when running the full test case suite. This file right here inside of this golden directory, all this is just the raw output of this JSON object. It's just saving the JSON object into this file. And that way, when we run the test cases, it's going to generate the JSON object freshly, brand new, and compare that to all the values are actually the same values. So that's why there's 2 separate files that have to be added. And in order to add them to the test cases, you just do a simple git add dot. This git add dot is going to add every file that's in your current meta HTML folder that's not currently in the repository. So you want to make sure that you only have these test cases that you have manually verified like this in your repository before doing that, before doing git add dot. And then you can say git commit and add a simple message like add a New York Times article, like that. And now if we were to push this onto GitHub, it would automatically run all the test cases. And so in the future, as I'm modifying the code, working on the code, helping it work for new web pages, we can make sure that I don't accidentally break it for the New York Times with this test case. Okay, so that's one example. And in particular, this is an example of when the type of the web page is an article. I want to take a look next at what to do when the type of web page is not an article, just so that you can see some of the differences that arise. So switch back over here, and I'm going to open up a new tab, still on the New York Times. Let's go to newyorktimes.com. And I'm going to find a page here that's not an article. So if I, let's go to the opinion section. And there we go. And now this page right here, this opinion page, is not an article. That it's sort of a collection of articles. And in particular, it's all the collection of articles that were published most recently, published today. But there's a lot of dates on this page. So here's, it just says 2 hours ago there. Let's scroll down. Here we go. Here's a bunch of dates down here. And we don't want the meta HTML library to look at this, find a random date for a random article like this, and think that this non-article page was published on this date. So we have to manually verify not only that it correctly extracts the date when there is a date, but also that it correctly does not extract a date for web pages that are not articles. And so in order to do that, I'll again copy and paste the URL up here at the top, come back over to my terminal session, and rerun the test/testgolden.py file. Importantly, I'm going to not only delete the URL, not just delete the URL, but also delete this -- save. And the reason is because when I'm first looking at this web page, I don't yet know if meta HTML is getting the correct results or the incorrect results. So I don't want to save this test case yet. I'll go ahead and run this. It'll take a second to download it and process it. And here is the outputs. You can see under timestamp published, it's giving us a null value, and that's great. That's what we wanted because it's not an article. There was not one particular date that it was published on. There were a lot of dates inside of there, but those were for other articles that it linked to. So that's great. It's null. And then the type here is labeled as unknown. In general, if something is not an article, it could be labeled as unknown or in a handful of other categories. But as long as it says unknown, or as long as it says anything other than article, it's okay. It passes the test case and it should be added. So here, it's correct. So we're going to add it to our suite of test cases. And again, doing that by pressing the up arrow button. And now you can see I can add the -- save at the end over here like this. Run that. And it'll take 10 to 15 seconds or so because it has a little bit more work to do when it's actually saving the test case than when it's just viewing the output of it. And then after this, I will rerun that git add command and the git commit commands in order to actually register these test cases with GitHub. So first, git status. We'll see that, okay, there's those 2 files that were created. Again, I'm just checking that there's exactly one in the .cache and one in the .golden, and not any other extraneous files not related to test cases. In this case, I added both of these 2 tests as 2 separate commits. It would be perfectly fine to have combined them together in a single commit. Either way is fine. And let's git commit add New York Times, and I'll say non-article this time because it's not an article. Whoops, I forgot to do git add dot, and then rerun the git commit command. And that's great. Those test cases have been created, and they've been saved. That's everything that you need to do when the meta HTML library already was able to extract the information from the web page. So somehow for the New York Times, they were following one of these standards and they did it correctly. So we've just told the meta HTML library that New York Times is already taken care of. No special work has to be done for the New York Times. For these other web pages that don't just work automatically, either the dates are wrong or it's not getting a date, something like that, some manual work has to be done to edit the meta HTML file itself, or edit the meta HTML library itself. And I'll just quickly highlight the big picture idea of what those changes look like so you can get a feel for it. But this explanation right here is probably not enough for you to make these changes yourself, and that's okay. And so what I'm going to do is I'm just going to look at one file in the source code here. So all the source code, all the Python code is in this meta HTML folder, and then all the information that's being extracted is in this property folder. And I'm going to look at the timestamp information. So there's timestamp, and under timestamp there is a published.py. So that's the file that I want to open up, and we'll open it up with Vim like this. Let's delete the cache. And then inside here is a bunch of rules for actually extracting this information. And there's sort of three categories of rules. JSON paths. This is for web pages that have JSON inside of them that encodes the publication date. And these rules are for how to actually extract it out of those JSON objects. Any of these rules, if they have a host name or a domain name on the left-hand side, these are, the rule applies only to that domain name. If the rule has none on the left-hand side like this, then it applies to every possible domain name. So JSON paths are a little bit confusing. The most simple, and these are pretty rare to have to work with. The most common technique that people use is called an Xpath. And here, this is when information is just placed directly in the HTML. And if I scroll down, you'll see that there's a lot of these Xpath rules that have been sort of hard-coded already into the library. These are all of the web pages that just aren't choosing to follow any sort of standard about how to store their timestamp published information. And so somebody had to go in here and manually develop these rules to extract this information. You see, yeah, there's lots of them specific for just different host names. And then at the end, there's a handful of these generic rules that will work on a lot of different web pages. The last set of rules are regular expression-based rules, and this is for when information is stored actually in the URL of the web page. Some web pages store their date information in the URL, and so that's what this is for. So the most common way, again, like 99% of cases, are this Xpath way. And in order to add a new test case, in order to add support for a new host name, you have to put on the left-hand side here, whatever the web page is that you're working with. And then on the right-hand side, this is called an Xpath. And this is a sort of a formula that specifies exactly where in the HTML that the information is stored at. In this case, well, let's see. So XPaths can be fairly complicated. It's really its whole programming language, understanding how XPaths work. But essentially what this says is that there is an HTML tag somewhere in the web page called div, and that tag has a class label called updated. And so whatever the contents of that HTML tag are the date that the web page was published on, and that's what we should use as the timestamp published. Um, yeah, you're welcome to try. If you come across a web page that doesn't work, try creating these XPaths, but probably it would be good at that point to reach out to me and say that, hey, I've encountered something, I'm not sure, or I've encountered a web page that doesn't work. I'm not sure how to go about finding the right XPath to create for that web page, and then we can work sort of one-on-one on that particular problem for a little bit to figure out what the correct syntax here is. Yeah, so quick summary of everything. This meta HTML library is extracting this information, which I'm using in the other parts of my research. And the way you can contribute is by doing creating test cases for me. And the simplest way to do that is just pick a web page and apply that test_golden.py file to the web page. Hopefully it works, and if it works, add it into the repository. But if it doesn't work, then that's when you'd have to do this XPath in this timestamp/published file, and actually creating what that XPath is probably something that that I can help you out with. So I look forward to hearing from you all about this, and I will see you later.